Alright guys, let's settle down please. Wait a second, something's off. None of you are here. Okay, this is weird. We're just gonna pretend like this isn't happening. You're not in your living room, I'm not in your screen, and let's just jump into it. Earth science. The first thing I want to talk about is probably my favorite thing. You guessed it. Reference tables. So we're going to talk about pages 2 and 3. We're going to talk about, the New York State maps, and then we're going to talk about pages 8 and 9, which is about the geological timescales. And then we're going to know about the Cambrian, Ordovician, and Silurian, and everything with the dinosaurs, and the trilobites, and the Earths. All right, let's calm down. So let's say you need to go shopping before all the stores sell out. So you look in the pantry. How many masks do I need? How many bottles of Lysol do I need? How many rolls of toilet paper do I need? These are important things to know. But what you got to do is look in the pantry, look in the fridge and whatever. You see what you have, you see the information, and then you write it down on your shopping list. I mean, let's be real on the Amazon app, but that sort of thing, you need to look at it, because a lot of times the answer is right in front of you, and all you need to do is look. So the first thing we're going to talk about is the map of New York State. There are different types of landscapes that are on that, and to help us explain the difference, we're going to ask Mr. A to tell us the difference between a plateau and a mountain. So, if you will.
All right, so a mountain is like very high up, but it's like tilted. A plateau is going to be like very high up, but it's going to be flat. So that's the difference. A mountain is tilted, and a plateau is flat.
Okay, thank you for that. Let me add a little bit more detail, just a drop. When you have layers of Earth, what happens is these layers get deposited over time. So that means every little layer is going to be from a specific time period. And the more layers you got, the older that section is. Now the entire Earth as a whole is made out of giant slabs of rock. Yes, a bunch of layers on top of each other, but remember we talked about crustal tectonic plates? These giant plates are always moving towards or away from each other, or side by side. What happens when you have bedrock and it begins to tilt because of these movements? For example, you can have on two sides, the plates begin to push towards each other, they begin to fold the bedrock, it begins to curve in like this shape over here. Another thing that can happen is where you'll have just in one direction plates pushing, and the bedrock begins to rise up in one direction. This is called faulting. So mountains are going to be very high off the ground, but they're going to have diagonal or tilted bedrock. Plateaus, kind of like the Grand Canyon, is going to be flat bedrock, but sections of it are gone. So it's very high up, but the layers are flat. A plain is going to be flat layers, but it's going to be very low down. It's going to be near the water. So now that we know the difference between a mountain, a plain, and a plateau, scroll down. You'll see some questions. Make sure to answer these questions about what we just learned. And as we go through it, we will stop and start. You will have the chance to answer these questions. Also, once we're done, make sure that all the questions are filled out. Put your email in and send it in to me and hit submit. So make sure to hit that submit button so I got your answers. And you got good grades, you hit that notification bell squad. Alright, let's get back into it. I'll just wait for you here while you answer that question. I've got nothing better to do. Say you lived in a good neighborhood, and every day the paper boy comes and brings you a paper, and he puts it on your doorstep. But you don't collect it because you're lazy, but you tell everybody, I'm being environmentally friendly. Okay, so after a while, you're going to have a large stack of newspapers sitting there. If I asked you which one came first, you would say, using common sense, that the bottom one is the oldest, and that all the ones were put on top, assuming that nobody touched it in this early pile. The same thing applies to layers of rock. The one on the bottom is always going to be the oldest, and as you go up, it gets younger.
Duh.
Quiet down, please. Thank you. Another thing you need to know about rocks is that they're always deposited horizontally. These newspapers are always put flat. If you see a big mess and a big pile, and it's all tilted, kind of like we talked about with the folding and faulting. It happens after the newspapers were put there. Another thing that happens after the newspapers were put there, or after the rock layers are put there, is that whatever happens to them happens afterwards. So if there is a crack in the rock, it had to have happened after the rock was there. The same thing is if magma pushes up through the rock layers, that intrusion, we talked about igneous intrusion, happened after the rock layers were there.
Duh.
Quiet down, please. Okay, enough. I don't want to have to send you to the principal. Thank you. Every day somebody delivers milk to the yeshiva, and it's someone's job to put it into the fridge. And when you take a look at it, you will see that the oldest milk is in the back, the youngest milk is in the front. We got this concept already. But what happens if one of the milk is spoiled, and you know the milk from Tuesday is spoiled? So you walk in, you take a look, all right, Sunday's in the back, Monday's the next one, Tuesday's here. But what you don't know is that one night somebody came in and took the bottle of milk. I mean, unlucky them, but at the end of the day, how are you supposed to know which milk is the correct one? This problem is called unconformity, where you have something missing from a sequence. You have an order, which is supposed to go in, and now it's missing. What are you supposed to do? The same thing happens with rocks. You have these layers, and some of them are missing. Let's take a look at this video.
Everywhere we looked, Steve showed me evidence of the incredible power of moving water. He quickly laid down these enormous layers, then quickly eroded them away. Steve wanted to show me where the floodwaters first hit the continent, so he took me deeper into the canyon. Stephen, you said you were going to bring me to the bottom. You weren't kidding, were you? We're at the bottom, aren't we? So we're in this big side canyon to the main Grand Canyon, and we're looking at the granite basement rock, which is the core of the continent, if you will. And then we see the flat-lying strata on top of it. The boundary between the granite rock below and the Tapete sandstone above is this surface we call the Great Unconformity.
So how do we solve this problem? Well, the simple answer is you match them. You take a look at the patterns of rock layers. For example, if you have red, yellow, red over here, and you have red, yellow, red over here, chances are, in a simple way, that they're going to be the same rocks, just very far away. Another much better system to use is what's called index fossils. How do index fossils work? So, fossils are organisms that lived and then died and got buried in the rock. So, you want this organism to live over a very widespread area. That means it can exist in North America, South America, Africa, Asia, all over the place. Okay? In China, it's going to exist everywhere. But what you want to know is that it only existed for a short period of time. That way it's only going to be in a very small layer, or one layer.
But Mr. Ackerman, how do we know how to answer the question?
Well, glad you asked. The way you would know how to answer this question, if you see it, would be to look for a fossil that is in every column, but only one row. I'll say that again. Look for the fossil that's in every column, only one row. That way, it lived over a widespread area, it's in many columns, but only a short period of time, only one row. Alright, so scroll down, I'll wait here, you check out the question on this down there. So let's bring it all back to the maps now. Let's pull up the map on page 2. This map is a pretty basic map, no premium features. All it shows you is New York State and the areas that have different types of landforms. Some have plains, some have plateaus, some have mountains. Which one are they? Let's find out. But that's all it shows you. If you take a look at the one on page 3, what you will see is that there's a lot more information that's given. Page 3 is an upgraded version of the same map. The first thing that they tell you that stands out is the names of the cities. So if I tell you, for example, Albany, you'll find Albany on the map on page 3, and then reference page 2 to see which area it is. Another thing that they give you is latitude and longitude of New York State. We're not going to get into that right now, but just know that if you need to find it, it's on page 3. And finally, to tie it in what we were talking about, fossils. We've discussed fossils and time periods on the previous test, but this time, all we need to know is what time period and what kind of rock it is. Well, if you take a look at the patterns on page 3, you will see that the map has different sections with different patterns. These patterns match to the bottom of the page where you have the key. The key will tell you 2 things. It will tell you what time period it's from. So you can match that to pages 8 and 9. And finally, it will tell you what type of rock it is. Is it sedimentary? Is it metamorphic? And specifically what kind of sedimentary and metamorphic it is. Okay, that's all you need to know for today. Make sure to scroll down, answer those questions at the bottom, and submit it. Let's get through this together, and I'll see you next time.
Pretty much.